Let us now have another example of how to optimize a transportation problem using the stepping stone method. Let's now begin with the use of the greedy method as our heuristic in coming up with our initial tableau. So if you would recall, the greedy method simply asks us to choose in sequence the least cost cell. Let's begin. So looking at the body of the tableau, the least cost cell is the one that has a cost of 5. How many units can we now allocate to that cell? It's now a choice between the supply of Laguna, which is 80, and the demand of Davao, which is 40. So we now choose the lower value, which is 40. With that, we have met the total demand of Davao, so we now eliminate the remaining cells in that column. After which, we reduce the supply of Laguna by 40. So from 80, it goes down to 40. From the remaining cells, our least cost cell is now the one with the cost of 7. There are 2 7s. And as I mentioned before, you can choose arbitrarily which one you would like to analyze. So in this case, I would choose the one of Laguna going to Cebu. How many units can we allocate to that cell? It's now a choice between the remaining supply of Laguna, which is 40, and the demand of Cebu, which is 70. And we choose the lower value, which is 40. That would deplete the total supply of Laguna, so we now eliminate the remaining cells in that row. After which, we reduce the demand of Cebu by 40, so from 70 it goes down to 30. From the remaining cells, the least cost cell is now the one with the 7. How many units can we allocate to that cell? It's now a choice between the supply of Batangas, which is at 120, and the demand of Iloilo, which is 50. We choose the lower value, which is 50. And with that, we have met already the total demand of Iloilo, so we now eliminate the remaining cell in that column. After which, we reduce the supply of Batangas by 50. So from 120, it goes down to 70. From the remaining cells, our least cost cell is now the one with a cost of 8. How many units can we now allocate to that cell? It's now a choice between the supply of Cavite, which is 50, and the demand of Baguio, which is 90. And the lower between the two values is our 50. With that, we have depleted the total supply of Cavite, so we now eliminate the remaining cell in that row. After which, then we reduce the demand of Baguio by 50. So from 90, it goes down to 40. Sorry. And from the remaining cells, our least cost cell is now the one with a cost of 10. How many units can we now allocate to that cell? It would be a choice between the remaining supply of Batangas, which is 70, and the demand of Cebu remaining at 30. So we choose the lower value, which is 30. That would enable us to meet the total demand of Cebu, and then we again have to reduce the supply of Batangas by 30 this time. So from 70, it goes down to 40. And since this example of ours is where your total supply is equal to your total demand, then the last cell should be able to satisfy both the remaining supply and demand values, which in this case is equal to your 40. So this is now the shipping pattern generated using the greedy method. So before we proceed with our optimization process, we first have to ensure that this particular tableau gave us a pattern that is compliant with the m plus n minus 1 rule, meaning the number of our U cells is equal to the number of our suppliers plus the number of our demand or destination points minus 1. So looking at the tableau, there are 6 used cells, or those cells where we have supply values assigned to them, which complies with the m plus n minus 1 rule, and therefore we can now proceed with our optimization. So again, my direction for analyzing the unused cells would be from top to bottom, left to right. I'll begin with the unused cell with the cost of 9. The closed path of that unused cell would be from 9. I go down to the used cell with the cost of 10. I go left to the used cell with the cost of 14. Then I go up to the used cell with the cost of 8, back to our unused cell with the cost of 9. And then with the alternating symbols, beginning with a positive symbol on the unused cell with the cost of 9, then the improvement index of our unused cell would be plus 9 minus 10, which is negative 1, plus 14, which is positive 13, minus 8 is positive 5. Next, a new cell, the one with the cost of 11. The closed path of that a new cell would be from 11. You go down to the used cell with the cost of 5, left to the used cell with the cost of 7, down to the used cell with the cost of 10, left to the used cell with the cost of 14, up to the used cell with the cost of 8, back to our unused cell with the cost of 11. And then again, applying our alternating symbols, beginning with a positive symbol, then you have the improvement index of the unused cell with the cost of 11 being equal to plus 11 minus 5, which is positive 6, plus 7, which is positive 13, minus 10, which is positive 3, plus 14 is positive 17, minus 8 is positive 9. Next, a new cell, the one with the cost of 16. The closed path of which would be from 16, you go down to 7. From 7, you go left to 14. From 14, you go up to 8. From 8, back to our 16. And then applying our alternating symbols, that would be plus 16 minus 7, which is positive 9, plus 14, which is positive 23, minus 8 is positive 15, which is the improvement index of the unused cell with the cost of 16. Next is the unused cell with the cost of 12, the closed path of which would be the adjacent cells. So from 12, you go right to 7, down to 10, left to 14, and then back to our unused cell with a cost of 12. So in terms of improvement index, that would be plus 12 minus 7, which is positive 5, plus 10, which is positive 15, minus 14 gives us positive 1. Next is the unused cell with a cost of 8, the closed path of which would be from 8, you first go down to 7, then left to 10, up to 7, back to our 8. So in terms of improvement index, that would be plus 8 minus 7, which is positive 1, plus 10, which is positive 11, minus 7, which is positive 4. And finally, we have the last unused cell to evaluate, the one with the cost of 6, the closed path of which would be its adjacent cells. So from 6, you go left to 10, up to 7, right to 5, down, back to our unused cell with the cost of 6. So in terms of improvement index, that would be plus 6 minus 10, which is negative 4, plus 7, which is positive 3, minus 5, which is negative 2. So looking at our improvement indices, the one that is negative is from our analysis of the unused cell with the cost of 6, or from Batangas going to Davao. So based on process, we again retrace the closed path of that particular unused cell. So from 6, you go left to 10, up to 7, right to 5, back to our 6. Then we again reassign our alternating symbols, beginning with a positive symbol on the unused square that gave us the negative improvement index. So you have there the plus, followed by minus, plus, and minus. Then we are to isolate those cells in our closed path where we have assigned the negative symbols, and choose which one contains the minimum number of shipping units assigned to it. So between a value of 30 versus a value of 40, we choose the value 30. And then we again follow the symbols. So in the next tableau that we're going to create, the Batangas to Davao cell, which is originally a blank cell or an unused cell, would now contain the value 30 because we assigned there the plus sign. In the cell of Laguna going to Davao, the original value is 40, but since we assigned there a negative sign, then 40 minus 30 would be 10. That would be the new value of that cell in the next tableau. Then, for the cell Laguna going to Cebu, wherein the original value is 40, but since we assigned a value of 10, then that would be 40 plus 30 gives us 70. So, the last cell is the one of Batangas going to Cebu, wherein the original value is 30, but that is the value that we've been adding and subtracting. Therefore, in the next tableau, that cell would become blank in order for us to maintain the m plus n minus 1 rule. So again, in terms of transition, this is the first tableau going to your second tableau. Again, the cell Batangas to Davao is originally blank. It now contains value of 30. The cell Laguna to Davao originally has a value of 40. It would now contain a value of 10. The cell Laguna to Cebu originally has a value of 40. It would now contain the value 70. And the cell Batangas to Cebu originally has a value of 30. It would now become blank. So we maintain the number of used cells equal to 6, which is the requirement for the m plus n minus 1 rule. Let's now analyze your second tableau. So again, I will be analyzing each unused square from left to right and then top to bottom. I'll begin with the unused cell with a cost of 9. The closed path of that unused cell will be from 9, you go down to 7, go right to 5, down to 6, left to 14, up to 8, back to our 9. So in terms of improvement index, that would be plus 9 minus 7, which is positive 2, plus 5, which is positive 7, minus 6, which is positive 1, plus 14, which is positive 15, minus 8, which is positive 7. Next, a new cell, the one with a cost of 11. The closed path would be from 11, you go down to the U cell with a cost of 6. Then go left to 14, go up to 8, back to 11. So in terms of improvement index, that would be plus 11 minus 6, which is positive 5, plus 14, which is positive 19, minus 8 is positive 11. Next is the unused cell with a cost of 16. The closed path would be from 16, you go down to 7, go left to 14, go up to 8, back to our 16. So in terms of improvement index, that would be plus 16 minus 7, which is positive 9, plus 14, which is positive 23, minus 8 is positive 15. Next is the unused cell with a cost of 12. The closed path of which would be from 12, you go right to the used cell with a cost of 5. Then down to 6, left to 14, back to our 12. So that would be plus 12 minus 5, which is positive 7, plus 6, which is positive 13, minus 14 gives us an improvement index of negative 1. Next is the unused cell with a cost of 8, the closed path of which would be the adjacent cells. So from 8, you go down to 7, left to 6, up to 5, back to our 8. So you have plus 8 minus 7, which is positive 1, plus 6, which is positive 7, minus 5 gives us an improvement index of positive 2. And finally, we have the last unused cell to evaluate in this tableau, which is the one with the cost of 10, the closed path of which would again be its adjacent cells. So from 10, you go up to 7, then go right to 5, down to 6, back to our 10. So that would be plus 10 minus 7, which is positive 3, plus 5, which is positive 8, minus 6 is positive 2, the improvement index of that unused cell. So looking at our improvement indices, we still have a negative value, and that came from our analysis of the unused cell with the cost of 12, or the cell of Laguna going to Baguio. So next step would be to retrace the closed path of that particular unused cell, which in this case is from 12, you go right to the used cell with the cost of 5, down to the used cell with the cost of 6, left to the used cell with the cost of 14, back to the unused cell that gave us a negative improvement index. After which we assign our alternating symbols, beginning with a positive symbol on the unused cell that gave us a negative improvement index. Then we isolate those cells in our closed path where we have assigned the negative symbols, and identify which one contains the least number of shipping units assigned to it. So between a value of 40 versus a value of 10, then we take up the value 10 and apply it to the symbols that we have assigned to the corners of your closed path. So that means for the cell Laguna to Baguio, it would now contain a value 10 in the next tableau. For the cell Batangas to Baguio, originally it would have a value of 40, minus 10 this time would give you a value 30 in the next tableau. For the cell Batangas to Davao, its original value is 30, plus 10 this time would give us a value of 40 in the next tableau. And then for the cell Laguna to Davao, it contains originally a value 10, but that is the value that we've been adding and subtracting. Therefore, in the next tableau, that cell would become blank. So this is now the transition from the second tableau to the third tableau. So we repeat again the process. Again, I would be analyzing the unused cells from left to right and then top to bottom. Beginning with the unused cell with a cost of 9, the closed path would be its adjacent cells. So from 9, you go down to 7, left to 12, up to 8, back to our 9. So you would have plus 9 minus 7, which is positive 2, plus 12, which is positive 14, minus 8 is positive 6, the improvement index of the unused cell with a cost of 9. Next is the unused cell with a cost of 11. the closed path of which would be from 11, you go down to 6, left to 14, up to 8, back to our 11. Then in terms of improvement index, you have plus 11 minus 6, which is positive 5, plus 14, which is positive 19, minus 8 is positive 11. Next is the unused cell with a cost of 16, the closed path of which would be from 16, you go down to the used cell with a cost of 7, go left to the used cell with a cost of 14, go up to the used cell with a cost of 8, back to our 16. And then for the improvement index, you have plus 16 minus 7, which is positive 9, plus 14, which is positive 23, minus 8 is positive 15. Next, a new cell, the one with a cost of 5. The closed path would be from 5, you go down to 6, go left to 14, go up to 12, back to our 5. And then for the improvement index, that would be plus 5 minus 6, which is negative 1, plus 14, which is positive 13, minus 12 is positive 1. Next is the unused cell with a cost of 8. The closed path would be from 8, you go down to 7, go left to 14, go up to 12, back to our 8. So you would have plus 8 minus 7, which is positive 1, plus 14, which is positive 15, minus 12 is positive 3. And finally, we have the last unused cell to evaluate, the one with a cost of 10, the closed path of which would simply be the adjacent cells. So from 10, you go left to 14, up to 12, right to 7, back to our 10. So in terms of improvement index, that would be plus 10 minus 14, which is negative 4, plus 12, which is positive 8, minus 7, which is positive 1. So we again have here the tableau wherein there are no more negative values in terms of your improvement indices. And therefore, we stop the process, and the final step would be to compute for the resulting total transportation cost, which is the sum of the product of the values assigned to a cell and its corresponding cost. If you would notice, this is already the same pattern we got when we began with the northwest corner rule from the previous video. Therefore, the total transportation cost would also be the same, which is 2020. So as I mentioned before, whichever heuristic you prefer to begin with prior to your optimization, you would still end up with the same final answer once you apply your optimization technique. So this is your stepping stone method, which rely heavily on your visual skills because you are supposed to imagine the closed path of each and every unused cell when you analyze each tableau. So if you're not too comfortable about your visual skills, then you may want to go to the next video where I would already discuss another optimization technique, but one that already rely more on your mathematical skills.